Compute probabilities with equally likely outcomes. There's the key. All right, so probability is the likelihood of an event happening. And remember that the sum of all probabilities must be 1. So thinking about if we're pulling marbles from a bag, and we had like red ones, blue ones, green ones, and yellow ones. If we added all 4 of these probabilities together, and it was all the marbles in the bag, that would have to equal 1. So all the probabilities, every probability must be somewhere between 0 and 1 inclusive. Okay? 0 meaning never going to happen, 1 meaning always going to happen. So theoretically, probability of an event is the number of ways something can occur, right? This is what we want to have happen over the total possible. So it's what we want over the possible, basically. Okay, let's throw a fair 6-sided die. So think about a dice, right? It's got 6 sides. The possible outcomes are 1, 2, 3, and 4, 5, and 6. I don't know why I wrote them backwards. Please forgive me. Okay, but those are the possible outcomes. So what is the probability of rolling a 5? Well, if you look at our possible outcomes, only one of them is a 5. So our desired outcome, there's only one possible, but we have 6 total possible outcomes. So the probability of rolling a 5 is a 1 out of 6. Well, what about probability of rolling an even number? Well, 2, 4, and 6, there are 3 even numbers out of 6 total. So this would reduce to 1/2. Letter C, the probability of rolling not a 4. Now, there's 2 ways to do this, but one of them is to just count. Well, there are 5 numbers that aren't 4, so there we go. But sometimes we have a sample size that is pretty difficult or pretty large. So if we would say, okay, what is the probability of rolling a 4? Well, that's 1 out of 6. Okay, so together, not a 4 and 4 is all the probabilities, which means they have to equal 1. So think about this. If a probability of 4 is 1 out of 6, then the probability of not a 4 is everything else. So that would be 5 out of 6. Because look at your numerators, 5 plus 1 is 6, which is all the possibilities. And that's what we want. So the probability of not 4 is 5 out of 6. Let's do one more example dealing with a deck of cards. If you're not familiar with a deck of cards, that's fine. I'll try to explain it. But hopefully you've at least seen this before. So a deck of cards has 52 cards in it. There are 4 suits. There are hearts, diamonds, spades, and clubs. And each one of those suits has a card ace up through king. So it goes ace, 2, 3, all the way to 10, and then jack, queen, and king. So there are 13 cards of each suit. Okay, so what is the probability, letter A, probability of pulling a 10 randomly out of this deck of cards? Well, you have a 10 of hearts, a 10 of diamonds, a 10 of spades, and a 10 of clubs. So there are 4 10s in the entire suit, an entire deck, and there are 52 cards total. So that reduces to 1 out of 13. Now, to make this make sense, if we know there are 13 cards of each suit, and one of those 13 is a 10, then that would make sense, right? Because each suit, it's 1 out of 13. Okay. Letter B. What is the probability of pulling a heart? Well, if we think about this, there are 13 hearts out of 52 cards. That's one way to think about it if you're thinking cards total. Or you can say this, if this is a standard deck, there are 4 evenly distributed suits, and one of them is a heart. And 13 over 52 does in fact reduce to 1 out of 4, because out of 4 suits, one of them is a heart. Now, letter C, let's think about this. If part B gave us the probability of a heart, and that's 1 out of 4, then the probability of not a heart is everything else. So if 1 out of 4 is a heart, then 3 out of 4 is not a heart, right? Because the heart, right, the event and the complement of that event have to equal 1. And in fact, 1/4 plus 3/4 does in fact equal 1.